All right, y'all. So we're gonna go over scale factor and area today. Okay. All right. So when you measure with length, okay, when you are measuring the length of something, okay, you are typically working. I don't know. Maybe you're working in inches, okay, or maybe you're working in feet, okay, or even centimeters. Okay. So when you're, whatever unit you can use, those are all fair game. Okay. When you are working with area, okay, each of these has a corresponding unit. Okay. But when you're working with area, it's not just inches. Okay. It is inches squared. Okay. Or when you're working with the corresponding unit for in area for feet would be feet squared, or a square foot, right? Houses are typically measured with square footage, right? Or apartments or anything like that, right? So anything with land is typically with square feet, okay? Or centimeters even, right? Centimeters squared. Why did I do it in red? Okay, trying to be consistent here. All right, so centimeters squared. Okay, so these are all the corresponding units. These all relate to one another. Okay, now turns out not only is the corresponding one just go from inches to inches squared, or feet to feet squared, or centimeters to centimeters squared. Turns out the scale factor is also the same. Okay, so we're going to go ahead and use K as our scale factor for the length, and if that's the case, then your area scale factor, right, or the corresponding one, would be that same scale factor, but then now it's K squared. Okay, so note the similarities between all these, and let's actually look at an example where this is the case. Okay, so we're going to start simple. We're going to start with a square. Okay, so let's say you had a square of 3 inches, okay, by 3 inches. Okay, we know the area of that square, okay, would be, well, 9 inches squared. Okay, all right. So, but what about a bigger square? Okay, I'm going to go ahead and make this particular square 12 inches. Okay, and then 12 inches here as well. Okay, so 12 by 12. Now, the area of this square, okay, would be, well, 144 inches squared. Okay, writing the units here just kind of helps you. I'm not saying you necessarily need it on like a Google form or anything like that, but writing the units does help us kind of think about this relationship. Okay, now let's look at the relationship between the actual lengths. Okay, so I'm starting at 3. I'm going to 12. Okay, well, the scale factor here, okay, my K is going to be 4. Okay, my K is going to be 4 because from here to here, I am multiplying 4. Okay, so let's think about, that's the case here, right? 3 times 4 gets me that 12. But what is the case when I'm looking at area? Okay, I'm starting at 9 inches squared for this first shape, and then I'm going to 144. Well, we can't just multiply 9 by 4 to get 144. Well, what is the relationship? Well, let's think about it. Okay, well, we just learned that it happened to be K squared. Okay, so the question is, what is that K squared? Well, we could think about what that number would be, just kind of like how we did it earlier, right? We knew that 3 times 4 would give me 12, but all we had was these two. Okay, so 9 times what would give me 144? Well, in order to do that, we could just do real quick 144 divided by 9, and we're going to get 16. And that is consistent with what I just mentioned earlier. Okay, so, well, if this was, my K originally was K is equal to 4, K squared, okay, K squared is now, we know it to be 16. Okay, so remember, starting at K, scale factor for my lengths is K. Scale factor for the area is K squared. Okay, now for the formulas with all this stuff, okay, I'm still going to try to make, small shape red and then bigger shape blue. Okay, but here's the relationship. And then we'll make my scale factor just black. Okay? All right, so small shape was blue, right? Okay, I hope I didn't mess this up, but here we go. I think the small shape was red. Okay, unfreeze. Okay, all right, so the formulas here are going to be like this. Okay, now we're starting with the length. Okay, so that's an L. Okay, and it's going to be my length 1. Okay, and then we're going to go ahead and we talked about this relationship earlier. Okay, but that is going to be equal to so L times K. Okay, and then we're going to get out. Got to be in blue here. Okay, we're going to get out the length of the second shape, right? Blue's the big one, red is the smaller one, okay, in this case. All right, now the area, okay, if that's the relationship between the lengths, okay, well then the area relationship, okay, would be A1, right? This is area 1, okay? This is not like, you know, to the first power, or this is not to the second power. Notice that it's a subscript, it's below, it's not an exponent. Exponent would be up top, okay? So A sub 1, all right, times K squared, that's the big difference, okay? And then equals the area of the second shape, okay? That's the equation that we're going to kind of use here. It's the relationship between the length scale factor and then how the areas of those same shapes, right? Same shapes, how those two relate, okay? All right, so let's go ahead and look at an example. Now, actually, real quick, let's talk about why this is important. Okay, well, if you have a weird looking shape and you don't know, let's say you don't know the height, okay, well, you can't end up finding the area if the height is a part of the formula. Well, but if you end up knowing the scale factor, then you can kind of work your way around finding some of that information, right? If you have this, this, and this, and you know the scale factor, well, then you're able to find this, right? So if you have 3 out of the 4, right, either 3, right, pick out of these 1, 2, 3, 4. If you have 3 of those and a scale factor, you can find that last one that you're missing. Okay, or better yet, right? You could find the scale factor, right? If you had all 4 of these. Okay, so if you have you know, enough working parts to solve the equation, that's where this comes into handy. Okay, so let's go ahead and do an example. Okay, for our example, all right. So let's go ahead and put a smaller shape. Okay. And let's say it's a triangle. Okay. So for the triangle, okay, and let's say we've got a triangle and it has a length of 5 here, and we don't know the height. Okay, remember, that's where this formula comes into handy. We don't know the height. Let's say all we know is that that's a 5. And then we end up knowing the area. Okay, and let's say that the area here, okay, is equal to 40. Okay, so we've got a length here of 5, area of 40. Okay, and for the bigger shape, okay, for the bigger shape, let's say I know this length is 15. Okay, and then we are asked to find the area, okay, of the blue shape. Now, before I go any further, I do want to mention that you have to know that the two shapes are similar. Okay, you have to know that they have a scale factor, right? That's kind of implied with the scale factor. If the two shapes, right, like if this was not a similar shape and it was like a bigger, fatter triangle or something like that, it would not be similar, right? In order to be similar, you have to have proportion and you have to have the same angles everywhere. Okay, I just want to say that before we move forward. Okay, all right, now let's look at what we have. Okay, well, let's go ahead and fill in some of the stuff, right? This is my area 1. Okay, so it doesn't have it, right? But it is my area of the first shape, of the smaller shape. So I'm going to go ahead and write 40 here. Okay, well, the length, okay, the length of the first shape, right? L sub 1, okay, that's 5. Okay, and let's look at what we have over here. Okay, I don't have the area, so there's nothing I can do yet here. And then, but I do have the length, right, of that second shape. Okay, so I'm going to go ahead and write 15 up here. Okay, now we can do a quick, you know, some quick math here in order to find my scale factor, and then we're essentially done. Okay, so we can find my scale factor, well, by isolating k, and in order to isolate k, I've got to divide by 5. Okay, so essentially doing 15 divided by 5, therefore k, all right, is equal to 3. So k is equal to 3. All right? And since we know that, now we can actually find my area. Because if I know K, well, then I'm just, instead of, K here, I'm going to go ahead and write 3, because we just found it to be 3. Therefore, it's 40 times 3 squared. Okay, note you have to put in that 3 squared part. Okay, so you've got 40 times 9. Okay, so that 3 squared, right, ends up just being 9. Okay, so you've got 40 times 9, and then therefore your area, okay, of the second shape is 4 times 9, which would get you 360 units, right? I didn't include units, but this would be whatever those units are squared, okay? So that is the area, and that's how similar figures and area and scale factor and length all relate to one another.